All right, we want to talk about solving equations. I just want to introduce you to simple equations, what I call one-step equations, but some really big ideas. So the first idea I want to talk about is really what does equation represent? So let me just pull this over so we can see it. Here's an example of what we'd call a simple equation or a one-step equation. And it's saying that a variable, in this case a, but it could be any letter, plus 2 is equal to 5. Now the way I'd represent that is I always think about a balance scale. And what it's saying is that if I have some unknown quantity plus 2 on one side of the scale, that's the same as having 5 on the other side of the scale, and you'll see the two are equal. Now, when we solve an equation, we want to find out what is the value of the variable. What value of a makes this a true statement? In this case, it's really easy to see, but the idea that we want to get across is when we're solving an equation, whatever we do to one side of the equation, we must do to the other. So in this case, to get the a by itself, I would remove 2 unit tiles. But notice if I remove 2 unit tiles from the left-hand side, it's no longer balanced with the right-hand side. So to keep the balance, if I remove 2 from the left-hand side, I have to remove 2 from the right-hand side, and then I get that the variable a is equal to 3. So that big idea of subtracting from the whatever I do to one side, I do to the other side, is really what we're trying to get at here. So I'm just going to put this away, and we'll go back and we'll look at a model now. So the first thing I'm going to ask you to do is I'm going to give you a balance scale model, and I'm going to ask you to write an equation and then solve it. So in this case, what you'll notice is on one side, I have two of the variables two a variables. So I'm going to write 2 times a. And that is equal to, if we count them up, it's equal to 8 units. Now I don't want to know what 2 times a is, I want to know what 1a is. So to figure out what 1a is, I'm going to divide both of these groups into 2. So I'm going to divide this into 2 and divide this into 2. And if I do that, you'll notice that each group is equal to 4. Now symbolically, I would show it this way. Since it's 2 times a, the opposite of timesing is dividing by 2. So the opposite of timesing by 2 is dividing by 2. So I divide both sides by 2. 2a divided by 2 is just 1a or a, and 8 divided by 2 is 4. Okay, let's take a look at a second one. This one looks a little different. If I look, I have that variable a, and I've got 1, 2, 3, 4, 5 units. So that would be a plus 5, and that's equal to 1, 2, 3, 4, 5, 6, 7. Okay, so again, I ask myself, what can I do? What's been done to the variable a, and what can I do to undo it? So if I look, the variable a, we've added 5 to it. I want to undo that addition of 5. So I'm going to subtract 5 from both sides. Now, symbolically, I would show it this way. Minus 5, and I've got to do it to the other side. So if I take 5 away from here, I have to take 5 away from here. 1, 2, 3, 4, 5. And what you'll see is then I'm left with just a, and notice where the equal sign goes. It goes in between the two sides, is equal to 2. I know that often in elementary school, students are taught that when they start a new line, they put in an a. Now let's do it without the balances. Okay, so again, I look at the side that has a variable. Now, often it's the left-hand side, but it can be the right-hand side if you look at the second one. So in the first one, the variable x, we subtract 3 from it and we get 9. So what's the opposite of subtracting 3? Well, the opposite of subtracting 3 is adding 3. So I add 3 to both sides. And I want to keep this equal sign right in the middle. What happens to this side? Well, minus 3 and plus 3 cancel out, and I just get an x. 9 plus 3 is 12. So that means x must be 12, which makes sense, because 12 minus 3 is 9. Now if we look at this second equation, 36 is equal to x plus 4. So what's been done to the variable? Well, we've added 4 to it. The opposite of adding 4 is subtracting 4. But if I subtract 4 from this side, I must subtract 4 from that side. So that will give me just x on this side, because plus 4 minus 4 give me 0. 36 minus 4 gives me 32. All right, let's take a look at this third one. Now this third one often bothers students because they read it as 14 and then negative 2x. Now the question is negative 2 and what x? Is it Negative 2 plus x, negative 2 minus x, negative 2 times x, negative 2 divided by x. What is it? And if you look, there's nothing between the negative 2 and the x. Often students will think that's x minus 2. But that's not what it's saying. It's saying negative 2 times x. So the opposite of timesing is dividing. So I'm going to divide this by negative 2, and then I have to divide this by negative 2. And this is where our integers come in. Negative divided by negative is a positive 1, or just 1x, or x. 14 divided by negative 2, the signs are different, so it's going to be a negative 7. Okay, and last, this one also bothers students because it's a times. Or sorry, it's a divided, and often fractions bother students. But I look at this as x divided by 3. And what's the opposite of dividing by 3? Well, the opposite of dividing by 3 is timesing by 3. So I'm going to times this by 3 and this by 3. Now this side is simple. That gives me 18, but what happens here? Remember when I multiply by 3, that's really 3 over 1. And if you remember with division, we don't need a common denominator and we look for common factors. The 3's would divide out and I'm just left with 1x or x. So x is equal to 18. So I want you to try the first 2 sheets for me. There are what we call one-step equations, but I want to see the steps involved. I want you to show me what you've done to one side, you've done to the other. I want to see that equal sign carried throughout, right in the middle of the equation. Okay,